Okay, sorry for my screen being extremely small. Hopefully you can make this out. I want to make sure that you see the calculator that goes along with this. There we go. The rational root theorem. So I'm going to get to this real quick. The rational root theorem is a way to figure out what are some possible rational roots. It doesn't mean that all of these numbers are going to be roots or solutions or x-intercepts. It just means that these are the possible ones. So what you're going to do is you're going to take the factors of the last term, so in my case 4, and the factors of the leading coefficient, again 2, and make a fraction out of it. So the factors of 4, and I'm going to go with plus or minus 4, plus or minus 1. And the reason why the plus or minus is because I've got both a positive and a negative root. So plus or minus 1, plus or minus 2, plus or minus 4. Over the factors of last, so plus or minus 1 and plus or minus 2. So I'm going to go through and take all those numerators and divide them by 1. So I get plus or minus 1, plus or minus 2, plus or minus 4. Go through and divide them by 2, so 1/2, because plus or minus 1 over 2. Okay, now 2 divided by 2 is already on there, it's 1, so I don't have to worry about it. 4 divided by 2 is already on there, it's 2, so it's already on there. And there's my list of possible rational roots. Okay. Try this again. Okay, make sure it's in standard form. There's my leading coefficient of 1, so the factors of 9 over the factors of 1. So plus or minus 1, plus or minus 3, plus or minus 9, all over plus or minus 1. Now, none of them are going to change because I'm just going to be dividing by 1. So there are my 6 possible rational roots, or in this case, rational zeros. Now, we've talked about the fundamental theorem of algebra. Basically, it's saying that the exponent tells you how many solutions there are. So it should have 2 solutions or 2 roots. This is a 5th degree polynomial, so it should have 5 solutions or 5 roots. And I'm going to show you how we're going to find all those possible roots. Okay, here's your list, or here's the list I'm going to come up with. I'm going to take the factors of 15, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. And I'm going to divide them by plus or minus 1. Again, just like the last time, dividing by 1 is not going to change anything, so this is the list of my possible roots. This doesn't mean that they're all roots, it just means that they're my possible ones. Now, in the olden days, you would go through and you do synthetic division for all these to figure out which one works. But since we got assistance with some little technology, I'm going to show you how to use your graphing calculator app. Okay, I use the graphing calculator. It's the same thing as the graphing app. So over to the right here, you see this y equals button. You press that. I've got something in it, so I go over to delete and just keep on hitting delete till that's gone. And I'm going to type in my equation. Okay, and by equation, I mean this function guy right here. So, very important, use the X button that's right next to this matrix right above it. So X, I'm going to use the little hat or caret button to raise it to the 3rd power. Arrow over just to make sure that I'm no longer an exponent. And plus, okay, X to the 2nd power minus X plus 15. Go up here to hit graph, and the graph should show up. Now, if you see here, it crosses at -3. So that means that my x-intercept is -3. That's going to be one of my roots. Now, to use synthetic division to check to see if that root is an actual root, and I know it is, I'm pretty sure it is, I'm going to use synthetic division. So here's the number I'm testing. Here's my coefficients, 1, 1, -1, and 15. Okay, I'm going to drop the first one. Multiply, add, multiply, add, multiply, add, and good. I get a remainder of 0. That's good. That means that it is a root. And my cubic is now, by synthetic division, a quadratic. And since it's a quadratic, I can set that equal to 0, and I can solve by using the quadratic formula. So x is equal to plus or minus the square root of 4 all over 2. and 2 plus or minus. I think that's going to work out to be the square root of negative 16, so in 4i all over 2. And I can reduce that. I can take them all, divide them by 2, and get 1 plus or minus 2i. And along with that 3 right here, would give me the 3 roots that I'm looking for. Okay, now what happens is imaginary numbers are always going to come in pairs. So if I get one imaginary root, I'm going to get a second imaginary root to go along with that. Okay, so here we go. Let's try another one again. List all the possible roots. So I'm going to take 4 and 2. So plus or minus 1, plus or minus 2, plus or minus 4, all over plus or minus 1, plus or minus 2. So if I divide them all up by 1, none of those are going to change. I think the only one that's going to add to it is I take 1 divided by 2 to get 1/2. Okay, because 2 divided by 2 is 1, it's already in the list. 4 divided by 2 is 2, it's already on the list. Graph, I'm not asking you to actually do the graph, but you go to your graph and calculator, go to y equals. This time I hit clear to clear the whole thing. Okay, type in my 2x raised to the 4th. Make sure you arrow over once so it's no longer a little dash there. There we go. Plus 3x to the 3rd. Okay, and then I'll arrow over once. Minus 6x. And then I've got plus 4. Hit graph. Oh, didn't cross the y-axis, so maybe I missed something here. Yep, I missed the squared one. So there's squared minus 6x. There we go, hit graph. There we go, now it crosses at, I don't know, it looks like a -2. Okay, so what I'm going to do is my synthetic division. And just to save myself some room, I'm going to start doing that right there. And so 2, 3, -6, -6, 4. -4. I get 0, good, so that means I'm down to a 2x to the 3rd minus x second minus 4x plus 2. And what I'm going to do is I'm just going to repeat this. And why? Because I don't have a cubic formula, I've got a quadratic formula. So I'll go back to y equals, clear that out, and graph this cubic that I've got. So 2x to the 3rd minus x to the 2nd minus 4x plus 2. Hit graph. Not quite sure, but not a whole number, but I noticed in my list I've got 1/2, so I'm going to try that out. I think that maybe that might be crossing at 1/2. Sorry for the lack of room here. I'm kind of writing a small thing. So here's 2. Half of 2 is 1. Add them together, get 0. 0, -4. Half of -4 is -2. Add them together, get 0. And that leaves me with 2x squared. There's no x, minus 4, and equal to 0. Now, I'm not going to do the quadratic formula this time. I'm just going to solve by square root. So 2x squared equals 4. Divide by 2. X squared is equal to 2. Take the square root, and x is plus or minus the square root of 2. So 1 answer, 2 answers, 3 answers. So my 3 answers for x, or sorry, my 4 answers are 1/2, -2, and a plus or minus the square root of 2. How did I know there was going to be a 4th? Because it was x to the 4th power. Now, I'm done. I'm not going to repeat that one at all because I have my quadratic. Why do I repeat this process if I've got a quadratic? So like if I started off with 6x to the, like, say, 5th power, then I have to do this process to get to the x to the 4th, and again to get x to the 3rd, and then again to x to the 2nd. We're not going to do that many, but the reason why I want to get it to the x to the 2nd, because I've got quadratic formula as an option. I've got factoring as an option, and I've got solving by square roots as an option. So that's solving for all the rational roots.